Now let's take a look at this figure 7-8. We're dealing with delta connected transformers. And notice we're wanting to determine what the winding current would be in relation to the phase-to-phase current. Now in the illustration, L1, L2, and L3 all have 150 amps. Now the winding current will be 58% of that current. So we find that in step 1 by taking 1 and dividing it by the square root of 3, 1.732, we get our 58%. 58% of the 150 amp phase-to-phase current is 87 amps. So the phase-to-phase current would be 150 amp, but the winding current would be 87. So that's why in 430.7b22 we can start a motor on a Y and run it on a delta. Remember, if it was Y connected, then the 150 amp phase-to-phase current is also 150 amp winding current. So that's why you get more torque, starting torque per amp, because the winding amps are the same as the phase-to-phase amps in a Y-connected transformer. Just the opposite in a delta-connected transformer. So once again, that's why you can start on a Y and run on a delta when you're installing a motor using that kind of a starting system. So that's what this figure 7-8 is illustrating, that the winding current of a delta connected transformer is 58% of the phase-to-phase current.